Hello there, kids! Welcome to our first online lesson in science. As you can see, we have METANOIA Learning Center G5.1.1 Properties of Matter. The G5.1.1 actually means Grade 5, Chapter 1, Lesson 1, the topic to be discussed. This is just for us to easily keep track of our lessons. Properties of matter. What is matter? Matter is anything that has mass and takes up space. Don't forget about that. Matter has mass and takes up space. Mass, the amount of matter that makes up an object. Takes up space actually refers to volume. It refers to the amount of space something occupies. So technically, everything around us is made of matter. You are made of matter. You have mass and you basically take up space. The thing that you're using to watch this video is actually made of matter. The air that you breathe is actually made of matter. The water that you drink is actually made of matter. If you remember our past lesson about solid, liquid, and gas, these are the basic states of matter. So going back, how would you determine if something is matter? As long as it has mass and takes up space, it is considered as matter. How would you know if you are taking up space? Imagine you inside a small room. If you invite all your friends in, if you notice that the space becomes smaller. The more friends getting in, the smaller space you have. So that's what you basically mean by taking up space. Properties of matter. We have physical properties and chemical properties. These are two of the many properties of matter. What do you mean by physical properties? Physical properties. For example, how would you describe this rock? If I were to ask you to describe this rock, how would you describe it? Are you describing it already? Or maybe not. Try to describe it. You might have described it through its size. You must have described it through its color. You must have also described it through its texture. For the size, you would have said it's small. You would have said it's big. So for example, in my case, I would describe it as medium. For its color, roughly around light brown. In my screen, it looks like it's light brown. For its texture, it's obviously rough. What you did earlier by simply describing this rock, we are pointing out its physical properties. Physical properties is a characteristic that can be observed or measured without changing the substance. So for example, earlier, by just simply looking at the photo, you're able to describe it. Physical properties of matter are classified as intensive and extensive. For intensive, we can describe its physical properties through color. Odor, taste, luster, malleability, ductility,
properties, malleability, and ductility. Malleability is the ability of a solid to bend or be hammered into other shapes without breaking. If malleable, A material can be flattened into thin sheets by hammering or rolling. Examples of malleable metals are gold, iron, aluminum, copper, silver. Because metals are malleable, blacksmiths have been able to hammer metals into helpful objects over the years. Compare a malleable metal to this piggy bank, which is not malleable. Because gold is malleable, it can be fashioned into jewelry. Ductility is a physical property of a material with the ability to be hammered into thin sheets or stretched into wire without breaking. A ductile substance can be drawn into a wire. Again, most metals are good examples of ductile materials, including gold, copper, and silver. Aluminum is not very ductile. Copper is used to make wires, and gold can also be used to make wire. This glass is not very ductile.
Conductivity. Combustibility. Hardness. Boiling point. Freezing point. Density. Solubility. Viscosity. For extensive, we can describe its physical properties through mass. Weight. Just to explain to you the difference between mass and weight. Mass basically refers to the amount of matter something is composed of, while your weight is actually the interaction of your mass with the gravitational acceleration here on Earth. Just to give you little information about that, it means that weight is basically equivalent to your mass multiplied to the gravitational acceleration here on Earth, which is, to be exact, at 9.81 meters per second squared, or rounded off to 10 meters per second squared. Which means that if your mass is 40 kilograms, we multiply that to 10 meters per second squared. So that basically gives us 40 kilograms times 10 meters per second squared, which now gives your weight equivalent to 400 kilograms times meters per second squared, or equivalent to 400 newtons. Mass is not the same as weight. Going back to our lesson, volume, length, width, height. Observable physical properties. We have our five senses. And all these five senses are connected to our brain. Without our brain, we won't be able to sense anything. And most likely, dead. Our five senses actually help us observe something through by simply looking at it with your eyes, by simply touching something, by simply licking something or putting something to your tongue, by simply smelling something. You can say that It smells good and it smells delicious. And of course, also through hearing. You might ask, how do we make use of hearing as part of the observable physical properties? One good example using your sense of hearing is through listening to an object falling. Once you drop a metal, you'll hear a different sound compared to dropping plastic. So by simply listening, you can tell what type of object fell. Chemical property is a characteristic that can be seen when a material is changed into a new substance. For example, this rusty iron, rusty roof metal, and some rusty tools. So if you observe, all these materials are made from metal. And over time, metal actually reacts to oxygen, which makes them rusty. As you can see, this is an example of a burned wood. A new substance is formed from wood to ashes. Chemical properties such as toxicity, oxidation states, heat of combustion, chemical stability, flammability, coordination number, reactivity, possible chemical bonds, and enthalpy of formation. But in this case, we are only going to talk about flammability and reactivity. Iron reacts to oxygen over a long period of time. This is a time lapse of a tin can. Again, if you observe, this is a time lapse of several months of a tin can exposed to oxygen. The result of this is called rust. This is one example of reactivity. Flammability is another example of chemical property. As you can see below, these are examples of flammability. This one is an example of exposure of evaporating acetone to flame. Observe the plate. They actually poured a certain amount of acetone there. And as soon as its vapor reaches the flame, flammability occurs. It's like a combustion, basically. And this one is the mist of citric acid to flame. And this one is nitrocellulose, which is composed of water, carbon dioxide, and nitrogen gas exposed to flame. I'm quite sure that you have seen these signs somewhere. Once you'll see this means that you're not supposed to expose these materials near to any fire or anything that can start a spark. Flammability is the ability of a material to burn or ignite, causing fire or combustion.